Trig identities. We'll have a look at a general triangle. We'll angle a theta. We've got the opposite, the adjacent, and the hypotenuse. Pythagoras tells us that opposite squared plus adjacent squared equals the hypotenuse squared. What we're going to do is we can divide through by the hypotenuse squared. So we get opposite over hypotenuse all squared plus the adjacent over hypotenuse all squared equals the hypotenuse over the hypotenuse all squared. What I did to one side, I did to the other. Everything's fine with that. Opposite over hypotenuse and adjacent over hypotenuse though are trig. So I can rewrite that as sine squared theta plus cos squared theta equals hypotenuse over hypotenuse 1. Sine squared theta plus cos squared theta equals 1. When we write in things like sine theta squared, just to avoid the confusion as to whether it's the theta squared or it's the entire function squared, saving us the need to write brackets in every time, we put that little squared next to the sine, so it's sine squared theta. So it's sine of theta times sine of theta. So sine squared theta. Same with cos, same with tan, same with all our trig. So that's one of our first identities. That's one that we really have to kind of remember. It's going to come up all the time. Another thing we can consider is sine theta divided by cos theta. Well, sine theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse. If I time both the top and the bottom of that fraction by the hypotenuse, then all the hypotenuses cancel. And I'm left with opposite over adjacent. But opposite over adjacent is tan. So sine theta over cos theta equals tan theta. Again, that's going to be a really useful identity for us. So these two basic identities are going to be really useful and really powerful for us to use. We'll have a look at an example. Solve sine theta equals 2 cos theta between the range minus 180 and 180. As it stands, that looks a little bit daunting, but it very quickly turns into something nice. If we divide through by the cos theta, we get sine theta divided by cos theta equals 2. We can rewrite that using our identity as tan theta equals 2. And our calculator tells us straight away that the inverse tan of 2 is 63.4. Tells us our other answers are plus 180 or minus 180. In this case, looking at our range, we're going to have minus 180. So we get minus 116.6. Another example here, we're going to do a little bit more kind of quadratic trig, but we've got cos squared and a sine. There's no way I can factorise that as it stands, so I'm going to have to change either the cos squared or the sine. I don't have any good way of changing the sine, but I can change the cos squared into something with sine squared in it. So our original thing says sine squared plus cos squared equals 1. So cos squared is the same as 1 minus sine squared. So cos squared theta is 1 minus sine squared theta. So we can sub that in. I get two lots of brackets. 1 minus sine squared theta minus sine theta minus 1 equals 0. Expand it all out. 2 minus 2 sine squared theta minus sine theta minus 1 equals 0. I'm going to move everything to the other side just to make everything positive. Times through by minus 1 if you want. 2 sine squared theta plus sine theta minus 1 equals 0. Now that's something that I can factorise. To get my 2 sine squared theta, I'm going to have a 2 sine theta and a sine theta. To get my minus 1, they both have to be 1. One has to be a plus, one has to be a minus. I'm going to have to make the 2 sine times the 1 the positive one, and then the other one has to be the negative one. That gives me two sets of answers. Sine theta equals a half, or sine theta equals minus 1. Quick sketch, sine theta equals to us a half, we know is 30. We also know the other one is 180 minus that, so that's 150. Sine theta equals minus 1, we know that's 270, just by looking at them. A little bit more involved example. Solve 3 tan theta equals 2 cos theta between the range minus 180 and 180. Looking at that, there's not much that kind of jumps out, so we do what we can. We can change tan theta into sine theta over cos theta. So that gives me 3 sine theta over cos theta equals 2 cos theta. Multiply through by that cos theta, that gives me 3 sine theta equals 2 cos squared theta. Again, I can't do much with it at this stage, so I'm going to have to change my cos squared into something involving sine squared. So I get 3 sine theta equals 2 brackets 1 minus sine squared theta. I can multiply all that out, stick it all onto the side that makes the sine squared positive. I get 2 sine squared theta plus 3 sine theta minus 2 equals 0. And again, factorising this is fairly straightforward. 2 sine theta and a sine theta, a 2 and a 1. I'm going to have the 2 pairing up with the 2. So I'm going to have 2 sine theta minus 1 and sine theta plus 2 equals 0. That gives us answers of sine theta equals 1/2 and sine theta equals minus 2. Quick sketch, sine theta equals 1/2, we've got 30 and 150. Sine theta equals minus 2. Well, sine only goes between minus 1 and 1, so it can't go down as low as minus 2, so there's no solutions. Thank you.